While it's true that a quadratic function like this one here, f of x equals x minus 6 quantity squared, is not one-to-one over its entire domain, it is possible to restrict the domain in such a way that results in a one-to-one function. So for example, if I lightly graph this whole function, this is a parabola that is shifted right 6. So I'm going to construct it over here starting at 6, 0. I can then look at the domain restriction, x is less than or equal to 6, which suggests that I want to look at only the part of this parabola that corresponds to this set of x values. So I'm going to keep the left side of this graph and erase the right side. Of course, I'm erasing some of my grid while I do this, but you get the idea. So that I get a graph that now does in fact pass the horizontal line test. So it is possible to make a quadratic function, for example, or pretty much any function one-to-one by restricting its domain. We can see that the domain here is the set we were given. X is less than or equal to 6 is the same thing as the interval from negative infinity to 6. And the range here is from 0 to infinity. Because we've made the function one-to-one, now an inverse also exists. So we're going to find that inverse. The process of finding the inverse really is the same as the process for finding an inverse of any symbolic function, but we'll have to be particularly careful about some of the steps. So we're given y equals x minus 6 quantity squared. I'm going to change that to x equals y minus 6 quantity squared so that I have swapped my input and output variables, and I'll solve this for y. The first thing I would do is take a square root of both sides. I have to consider both the positive and negative square roots here. And the square root on the right-hand side just gets rid of the square. Then I will add 6 to both sides, so I'm going to write this as plus or minus the square root of x plus 6 equals y. And the thing I have to focus on now is because I did the domain restrictions on that original parabola, I should get a function for my inverse. This doesn't look like a function with the plus or minus. I have to resolve which of these I really have in my inverse. Is it the positive square root or the negative square root? And to do this, I have to look back at the graph, or at least the domain and the range of the function that I already graphed that I'm taking an inverse of. So returning to that function, notice that it has domain from negative infinity to the 6. This has to be the range of my inverse. And it has a range from 0 to infinity. This has got to be the domain of my inverse. So this is one of the things that I can do to help determine which of these situations I'm in, right? So I'm going to write down the domain and range now for my f inverse. The domain is 0 to infinity. The range is negative infinity to 6. The next thing I'm going to do is think about what the graph looks like of these two parts of the inverse function. So if I draw just a quick little coordinate system, I'm not going for a perfect graph. This plus 6 here is a shift up 6. And the plus or minus means I have two graphs, one of which is reflected about the x-axis, the other of which is not. But the square root graph is the one that looks like a parabola on its side. So recall the y equals the square root of x looks something like this. So these two pieces of the graph, both shifted up to 6, the top portion would look like this. This is y equals the square root of x plus 6. The other piece is the bottom half of the parabola because it's reflected about the x-axis first. This is the graph of y equals negative square root of x plus 6. I need to figure out which of these is the inverse of that graph that I already drew. Now I could bring that graph into this also, but it's not really necessary because I know the range has to be from negative infinity to positive 6. So I can see now that this upper graph is out of my range, and therefore that's not the inverse of that function over its restricted domain. In fact, this is the graph that is in the correct range, and therefore my inverse function must be f inverse of x is equal to minus the square root of x plus 6. I don't have to state any sort of restricted domain for my inverse function because it already has the correct domain. I can't evaluate a square root function at negative values. My domain is already from 0 to infinity. So we can see that with these domain restrictions, we really do have to take bits and pieces from all the representations we know, or at least bits and pieces of the domain and range, the symbolic process, and perhaps the graph in order to tie everything together to really find an inverse.